For our project in power system course, the location of our fault is at 74 and 109 bus. For introduction, as we all know, power system stability refers to its ability to return back to its steady state when it is subjected to disturbance. The objective of our projects is to first to be able to work in group to solve complex power system problems. Second, to test a model of power system using Matlab software. And the third one is to analyze the dynamic response of following disturbance in a system. The next one is scope. The scope of our project is to simulate all generators using Matlab version 2016. The test system model used for this project is 50 machine and 145 bus system.
My name is Song William. Now I'm going to explain about the methodology part. Introduction. Power System Toolbox bring model of machine and control system for performing transient stability simulation that specifically cater to the need of microgrid and power system engineer. These dynamic models are coded as Matlab function. Matlab allows the user to solve their simple problem or equation with fast and efficient. The power system structure. The power system structure is the bus and line rating of specification matrices then used in load flow calculation of the power system. Those structures may represent the generation station, transmission, the distribution, and the load. Dynamic data. Generators are defined in the specification matrix. There are three types of generator model: the electromechanical or classical model, the transient model, and the subtransient model. Simulation control data. For transient stability simulation, some method for instructing the simulation program to apply a fault is required. Dynamic model function. There are 14 types of dynamic function. First, generator model, excitation model, power system stabilizer model, simplified thermal turbine governor model, simplified hydro turbine governor model, induction motor model, induction generator model, static VAR compensator model, thyristor control series compensator, load modulation control, HVDC line model, non-conforming load model, line flow function, utility function. Standard dynamic driver. Driving functions are provided for transient stability and small signal stability. This function provides an environment which requires only the system data to be specified and act much like stand-alone transient and small signal stability program. And the last one, expanding the capability of PSD. Since the source code for all functions is provided, a user may expand PSD to meet special modeling or simulation requirements. The following indicate the preferred form of dynamic model: model structure, method computation, and use of template.
Okay, so now I will explain the analysis of bus fault by using our Matlab. So first of all, we have to run our program software Matlab. Then we choose our model by launching an M file, and then we run the model. And first of all, from the program we are required to enter the bus fault location, and we have to key in the values. And after that, we have to insert a suitable range of the clearing time to allow the bus fault to achieve a critical stable condition. Usually the range or the step up between the range of the suitable the clearing time is by 0.1 second. So we will have to wait for the analysis of the result. If the result give us a critical stable condition of the bus fault location, so we can proceed to the next step, which is to our conclusion. Else, if the bus fault location haven't achieved yet the critical stable condition, we have to go back to our procedure to re-enter or reinsert another suitable clearing time. So until this step is repeated until we find a suitable critical stable condition for the bus fault location. Then we are done. Then we can compare. When we are done, we can compare our result of the critical, stable, and unstable condition of the bus fault location. That's all. Thank you.
Assalamualaikum and hello. My name is Nurul Hana binti Syekh Muhammad Musadi. My metric number is CE150240. So I will discuss the result that we get from this project. Firstly, according to the project, the total of the bus test system are 145 bus bar and 50 generators that are being used. So the clearing time set at 0.01 second. For my team, we have decided the non-volted fault at bus 74 act as disturbance, and we choose the bus of 109 as the clear bus. Actually, this project can related to the concept of turbine system, where the turbine and shaft are connected together and have same condition with this project. In stable condition, the turbine are rotate with the shaft together in control speed, while in unstable condition, the shaft and also the turbine reach the high acceleration and will broken apart. So this is the coding of stable case. We are try and error to get the fault, and after execute the code, we have applied fault start at 1.01 second and clear after 1.02. Actually, stable condition is can return normal or stabilize operating after it's subjected to have been some disturbance. So this is the waveform of wave voltage magnitude measured at the voltage bus without PSS and also with PSS. We can see the waveform are more clear and smooth compared to without PSS. Then the waveform of the rotor angle response and generator speed response. Also we compare with without PSS or with PSS. You can see the waveform are more stabilized than without PSS. For the second condition, it is critically stable case, and after execute the coding, we have applied fault at 1.17 second and cleared after 1.18 second. Actually, when it is contrast with stable condition, where the waveform are more peak than stable condition. And this is the waveform of the rotor angle response and generator speed response. And this is the final result of critically stable case. For the last condition is unstable case, where we apply the fault start at 1.19 second and clear after 1.20 second. So this is the waveform of wave voltage magnitude measured at the voltage bus. Okay, this is the range of stable case at 1.19 second to 1.20 second, where we can see it have distortion and sinusoidal shape waveform are broken apart. When it apply the time at 1.27 to 1.28, we can see there is unstable curve. So we can consider that fault at bus 74 can run until 1.19 to 1.2. This is the waveform of rotor angle response and generator speed response. And this is the final result. This is what I said. Ignore distortion and the sinusoidal shape are gone. And this is the unstable curve when it conclude as a stable condition. Thank you. That's all from me.
Assalamualaikum and a very good day to everyone. My name is Ieee Dato' Alia binti Shahrudin and my metric number is CE150171. Now, I would like to present my conclusion for our group project. As a conclusion, this report presents the transient stability analysis of 50 machine, 145 bus test system model for the fault occurred at bus 74 and bus 109. 4 cases are represented in this report, which is stable case, critically stable, critically unstable and unstable case. For stable case and critically stable case, the results show that the generators in the system are able to reach a new equilibrium point following a disturbance in the system. Critically unstable and unstable case, the system results show that one group of generators will accelerate and one group of generators will decelerate. That leads to the generators in the system unable to reach a new equilibrium point following a disturbance. The system will go unstable if the fault in the system is not clear after 1.34 seconds. This implies that protection and control system engineered to rectify any disturbance occurred at bus 74 and 109. The system provides the remedial control signals before 1.27 seconds. This information is critical to ensure stability of operation during transient event in the system. That's all for conclusion for our project. Thank you.